Hello students, welcome once again to my channel. In this section we want to talk about the ENSO. So this video contains methodological content. So let's quickly move on. Now when we talk about ENSO basically means the Nino Southern Oscillation. So in the next slide, let's try to brainstorm over here. Now we have ENSO, right? So ENSO, which basically means the Nino Southern Oscillation. Let's separate them into two. So we have the Nino and also the Southern Oscillation. Now when we talk about the ENSO, it basically occurs at the southern hemisphere, just below the equator. That is where the ENSO takes place. So when we talk about the Southern Oscillation, Southern Oscillation basically means oscillation which takes place in the southern hemisphere. Now oscillation is basically the to and fro movements from one phase to another. So we have something undergoing a to and fro movements from one phase to another. So that thing that is undergoing the movements from one phase to another is basically the temperature, not just any temperature, but we have ocean temperature or the sea surface temperature undergoing from one phase to another. Now these temperature can undergo Southern Oscillation from one cold phase to another warm phase in the Pacific Ocean. Now when we talk about the Pacific Ocean, we are basically referring to the northern part of the America, of the American continent, and also the eastern part of the Asian continent. So basically that's the general idea of ENSO. Now let's look at the next slide. Now ENSO is basically one of the most strongest climate drivers, especially in our climate or in our weather system. So it's most of the time it's one of the climate drivers of the Australian weather system. So let's look at the contents of this presentation here. So in the context of the presentation, we want to talk about what ENSO is. We also want to talk about the phases of ENSO, or the various phases of ENSO, and also how each of these phases occurs, and also the importance and also the interaction of these phases or ENSO, and also why we should care about Nino, and also how do you think scientists can predict Nino events, right? So let's quickly move on. Now what is ENSO? Now when we talk about ENSO, now the first point here says it's a disruption of ocean to atmosphere interaction in the tropical ocean. Now when we talk about the disruption basically means any variation or changes, right, that actually takes place when the ocean and the atmosphere interact, right? Now the ocean and atmosphere are always interacting, and one of the points is that the ocean and atmosphere interact. Their interaction are complex, are linked to each other complexly. So now when we take the atmosphere basically refers to the air, right? So we have air in the atmosphere, and it is one of the largest parts, right, which is actually responsible for what we call the ocean circulation. Now in order for the ocean to undergo a circulation, there has to be an atmosphere which actually influences the ocean circulation, and it influences the ocean circulation through what we call waves and currents, right? Through waves and currents. So when these phenomena are taking place, it's actually due to the atmosphere contributing to this ocean circulation through waves and also currents. Now the ocean on its own is also the part that actually regulates the temperature in the lower part of the atmosphere. So we have the ocean actually regulating the temperature in the lower part of the atmosphere. Now when you look at the ocean, you realize that ocean surfaces at the equator are very warmer, right, and due to insulation, and therefore we expect that there should be transport of warm water and precipitation from the equator, which is where insulation are very high, towards the pole. Now unlike the equator, unlike the pole, realize that the equator as warmer ocean surface. But if you look at the pole, because insulation there is indirect, it is not direct as compared to the equator, where insulation is very direct to the equator. At the pole, it is not direct and it has a kind of a slanted path. So the amount of solar radiation reaching there is very low. So we have cold condition in that particular region, and also we have warm condition at the equator. So what the ocean does is that it helps in what we call the even distribution of these solar radiation which is reaching the Earth's surface, thereby by transmitting warm ocean waters and precipitation from the equator towards the pole, and also the cold water from the pole towards the tropics towards the tropics or the equator. So it regulates the temperature by providing an even distribution of what a temperature balance between the equator and also the pole. Then also the ocean is also a reservoir of heat, right? So it's a reservoir of heat here. It's a reservoir of heat, but then also it has the ability to absorb, store, and also release greenhouse gases. So we take the CO2, for instance. CO2 the content of CO2 in the ocean is very large, so the ocean is able to accumulate or store this CO2, and these CO2 are greenhouse gases which are very important when it comes to the radiative balance, right? So the ocean is that's how the ocean actually regulates the temperature in the lower part of the atmosphere. So we have ocean to atmosphere interacting with each other, and through the interaction there is a disruption, and this disruption is brought about as a result of what? A varying or changing temperature or pressure. Now another point is that ENSO is actually a natural cycle in the Pacific Ocean. So it's a natural cycle which takes place in the Pacific Ocean. So we realize that it brings changes to our climate and weather through varying temperature, through changes in winds and also clouds. So these parameters or these variables come together to bring changes to our climate systems in our climate systems and also in our weather. Yeah. So in the third point we have a periodic fluctuation in the sea surface temperature, which is the El Nino. So we have the sea surface temperature, talking about the ocean, right? Varying temperatures along the ocean, and also the air pressure of the overlaying atmosphere, which is basically the air pressure of the atmosphere. So the main quantities are, or the main variables here are temperature and also pressure. Pressure as a result of which brings about a wind flow, right? Because wind moves from region of high pressure to a region of low pressure, right? So and this normally takes place in the Pacific Ocean, right? Now another point is that it is an irregular periodic variation, right? An irregular variation, changes in the winds and also the sea surface temperatures in the tropical eastern Pacific Ocean, affecting the climate of much of the tropics and the subtropics, right? So we have the warming phase and the cooling phase, right? The warming phase of the sea temperature is referred to us as the El Nino, and also the cooling phase is basically the La Nina. Then also, if you look at the globe over here, you realize that we have a color code over here. We have regions where we have low temperatures and regions where we have high temperatures. If you look especially along the equator, you realize that temperatures there are very high due to insulation. We have the orange and the red color representing that, and along the oceans, right, we have cold temperatures over there, or cold conditions in that particular region. Now let's talk about the phases, each of the phases of ENSO, right? Now we have what we call the normal condition, which is a neutral phase. We have the Nino condition, which is a warming phase. We also have the La Nina phase, which is just a cooling phase. Now one thing you should also take note of is that on average it takes about 4 years for each phase to swing from one phase to another. So let's take for instance we have the normal condition. It will take about 4 years to swing from one phase to another phase. So that's basically the general idea. Now let's look at how each of the phase occurs. So let's start with the under normal condition. So this is basically under normal condition, under neutral phase, we want to look at how the whole thing occurs. Now if you look at this figure over here, we have the the Pacific Ocean. So this figure is just representing the Pacific Ocean. Now, in this figure, we can see that trade winds, strong trade winds, which are the white arrows. So we can see the white arrows here, right, moving from the eastern Pacific all the way to the western Pacific, which is moving from America towards New Guinea and Australia. We have strong trade winds. The strong trade winds are basically the tropical easterlies, right, moving from the eastern Pacific all the way to the western Pacific, which are the white arrows moving in that particular region. But then along the equator, we have learned that we have insulation being high in that particular region. So ocean surfaces there are very high. So as the winds or the trade winds are moving towards the western Pacific, we realize that it pushes the warm ocean waters at the equator towards the western Pacific. So in that case, we have these winds push water that has been warmed by the sun towards the coast of New Guinea and Australia, right? Now, so what happens is that the warm ocean waters are being concentrated at the western Pacific. Now, what happens at the eastern Pacific? Now, under normal condition, the eastern Pacific experiences what we call the upwelling. Now, upwelling is basically the vertical transport of cool and nutrient-rich waters from the deep oceans of the waters to the surface. Now, because these the trade winds are flowing west, right, they are moving towards the western Pacific. Realize that we have deep ocean waters, right, moving towards the surface at the eastern Pacific, which is upwelling taking place in that particular region. So if you look at the thermocline over here, we have upwelling increasing, and we have upwelling increasing in the eastern Pacific and decreasing in the western Pacific. So we have cool nutrient upwards along the west coast of north and that. So we've said that. Then what happens at the western Pacific is that because the surfaces are very warmed up, what happens is that temperatures increases and also the moisture content also increases. The warm air will start to rise by convection, right? Now, as this warm air rises, adiabatic cooling takes place, therefore clouds are formed, and therefore we should experience some kind of wind. So heavy rains are therefore concentrated in the western Pacific. So we have convective activities taking place along the western Pacific in this particular region, right? So now what happens is that as this convective activity takes place in this region, one phenomenon that actually is very important when it comes to ENSO is what we call the Walker circulation. Now, what is the Walker circulation? Now, the Walker circulation are basically the winds that are blowing from the eastern Pacific towards the western Pacific, right? Now, when the winds from the eastern Pacific flow towards the western Pacific, what happens is that it carries this warm air. Now, the warm air then therefore travels eastward, right? So we realize that over here we have this warm air forming convective activities here. The warm air therefore traveling eastward in this particular section, and therefore towards the eastern Pacific, right? So realize that it travels all the way to the eastern Pacific, to the eastern Pacific over here, regions at the south of America, which is Peru, right? So when this happens, what happens is that as this warm air reaches or it goes up, what happens is that it reaches the end of the troposphere. So at the end of the troposphere we have warm air, but then also at the top of the troposphere we realize that we have cold condition or cool conditions over there. So we realize that we have a cold phase and also a warm phase. Now as this cold phase meets this warm phase, what happens is that it slowly loses its moisture content, right? The moisture content that is actually contained in this air is being lost, and therefore we now have dry air. Now this dry air also travels towards the eastern Pacific. So this dry air moves all the way to the eastern Pacific to the Peru coastal region, making that particular region very cold. And this is what we are referring to as the Walker circulation. It's basically the rising of air in the west and also the falling down in the east. So the rising of air in the west and also the falling down in the east is basically the Walker circulation. So that's basically the Walker circulation. So in this particular neutral phase, we realize that we have, so in this case, the Western Pacific over here will experience rain, cyclones, storms, and flood. But then in the Eastern Pacific, where there is cold condition, there is hard boiling conditions over there, then we usually experience drought conditions in that particular region. Alright, so that will be it for the neutral phase or the normal phase. Now let's look at the El Nino phase. Now in the El Nino phase, what happens is that the trade winds which were strong in the neutral phase will go weaker in this case. So you realize that, look at where the arrows are moving now. So they are moving in the opposite direction as compared to that of the neutral phase. So you realize that the trade winds will go weaker, and therefore as it goes weaker, now as a result of it weakening, what happens is that the winds will therefore move in the opposite direction, and therefore the warm ocean waters here. Now already in the neutral phase, the warm ocean waters were accumulated at the Western Pacific. So in this case, when it is moving towards the Eastern Pacific, what happens is that it carries along the warm ocean waters, but then at the central part of the equator, you realize that ocean waters there are already warmed up due to insulation. So what happens is that as it moves towards the Eastern Pacific, what happens is that it covers the central and also the eastern part. So in this case, the ocean surface therefore becomes warmer than usual. So therefore, in this case, you experience more of flood condition, more cyclones, more rains becoming heavy and stuffs. So then also in the Western Pacific, there will be upwelling taking place in that particular region, as in the neutral phase, where upwelling took place in the Eastern Pacific. In this case, upwelling will take place in the Western Pacific. So we realize that if you look at the thermocline, we have upwelling conditions increasing in the thermocline, and also decreasing over here in this region. So we have convective activities taking place in this region, because as the ocean surface becomes warmer, realize that there is rising of vapor, so there is rising of moisture, therefore clouds are formed, and therefore we expect convective activities to also take place. So we have ocean it alters the jet streams, right, causing rains to occur beyond their normal location. So we realize that most of the time it occurs at the central part, right, and then covers part of the eastern part of the Pacific Ocean. But then we still have the water circulation taking place in this particular region, because warm air rising, meeting cold air from the top of the troposphere. As they meet, what happens that slowly they loses the water content, and therefore move towards the Eastern Pacific with dry air, right, or with cold condition, and therefore that is where we can see the cold condition taking place in this particular section, right. So that will be for the Nino condition. Now in this region we expect flood, we expect heat waves, the global temperatures rising over here, right. But then also we expect drought conditions taking place at the Western Pacific. So that will be for the El Nino. Now if you look at the La Nina phase, the La Nina phase is just equivalent to that of the normal phase, but just that in this case the upwelling therefore becomes colder than usual. Now upwelling took place in the Eastern Pacific, as in the neutral phase. So upwelling is also taking place over here also, but then also the upwelling in the Eastern Pacific is actually characterized by cold condition than usual condition, right. It becomes colder than usual, right. So that is when we can have kind of drought condition taking place in this section, right. But then also we have convective activities taking place in the Western Pacific, where we see rains, tropical cyclone storms, and flood taking place in the Western Pacific. And as you can see in the case of the thermocline, you can see that there's a decrease in the Western Pacific where convective activity are taking place, and also increase in the thermocline at the Eastern Pacific where we have colder than usual conditions, right? All right, so that will be for each of the phases, right? Okay, so now let's look at a summary of all the phases here. So now let's look at this.
Conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impact, but eventually those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Nina, unusual.
Alright, so let's look at the importance and also the interaction of the ENSO. Now, in the first case, you realize that as you look at how the phases occur, you realize that there is an increase in the ocean surface temperature in the Equatorial Pacific. Now, if you look at it in the case of the El Nino, you realize that at the Central and the Eastern Pacific, you realize that there was warmer condition than usual, right? We had warmer conditions than usual, and therefore we had flood conditions taking place more, right? So one of the features of the ENSO is that it increases global temperatures, especially over the Equatorial Pacific. Then also there is it greatly affect the global weather. As we look at in other phases, we realize that there were some portions where we experienced convective activities, tropical cyclones, we were experiencing storms, heavy rainfall and stuff. But then in the opposite direction, we're experiencing drought conditions, which leads to potential bushfires and others, right? So it also affects global weather. Then also scientists also use oceanic and atmospheric data to predict ENSO events. So we have we'll look at it more with a diagram later in the slide. Okay, so now in the next slide we want to look at how do you think scientists can predict El Nino events. Now if you look at figure 1, we have normal condition. If you look at figure 2, we have El Nino condition. Now the red color there shows the sea surface temperatures is warmer, and the blue color shows sea surface temperatures being colder, right? So you realize that depending on where the cold conditions and the warm conditions are occurring, we can predict that this is a normal condition, this is a neutral phase, this is El Nino event, this is La Nina event. So that's how scientists can be able to predict El Nino events depending on where the warmer conditions are taking place and the colder conditions are taking place. Realize that in the normal conditions, the colder conditions are taking place at the South Americans, which is the Eastern Pacific, and also the warm conditions are taking place at the Western Pacific, which is Australia. Then if we come to the El Nino years, you realize that the warmer ones are taking place at the warmer ones are taking place at Australia, right? The central and also that of the whole of Australia. Then also the colder ones are taking place at the South America. So basically, depending on the position of where the conditions are taking place, scientists can predict that El Nino events are taking place in this part and in that part. All right. So let's look at why should we care about ENSO events, right? ENSO events. So one is that it brings about drought which and bushfires, right? Just in the case of La Nina, we realized that there was colder condition than usual at the Eastern Pacific. So over there, we realized that we can experience drought conditions which can lead to potential bushfires, right, taking place. Then also we have intense hurricanes. In the case of the warming phase, which is El Nino, we have heavy rains are being concentrated at the Western Pacific, so we experience convective activities taking place because ocean surface therefore becomes warmer than usual, and therefore intense hurricanes. Then also we have intense tropical cyclones being formed, and unless tropical cyclones, most of the time those tropical storms are formed of warm ocean surface. So if the ocean surface becomes warmer than usual, then we expect that there should be intense tropical cyclones and tropical storms being formed. Then also we have severe coastal flooding. That is in the case where rains are very high, right? We should experience coastal flooding. Then also we look at how do scientists predict El Nino events, right? So one, they predict El Nino events just by looking at the sea surface temperatures, right? That is basically the anomalies or the abnormal sea surface temperatures. The anomalies, when we talk about the anomalies, we are looking at the increase and decrease. So basically we are looking at the variations which actually takes place in the sea surface temperatures. When they see any anomalies in the sea surface temperatures, then they can actually predict that this is a Nino event, this is La Nina event or normal conditions. Then also they also look at the Southern Oscillation Index, right? The Southern Oscillation Index. Now the Southern Oscillation, as we said, is just a movement, right? The movement which occur in phases, right? But then we are looking at the variations or the changes in the air pressure. So because the Southern Oscillation Index is basically a seesaw, right? Increase and decrease in the air pressure systems between the Western and the Eastern Pacific. That is actually linked to El Nino. So scientists look at all these indexes, these data, these anomalies, and with this data that they have, they can predict El Nino events, right? So that'll be it. Yes, references, and thank you very much for joining me in this session. I hope this session was helpful. If you are new here, please like, subscribe, and also hit the notification bell, and leave a comment. If you have a question, leave a comment at the comment section, and I will get back to you. Thank you very much for joining me in this session. I will see you guys in another section.